So thank you. I'm going to be talking about interprocess audio today, which is a bit more technical and nuts and bolts than what Ernst so eloquently described just now. But it's essentially the same kind of thing, where it's about sharing. It's about sharing and collaborating with music. And this is one way that iOS allows you to share and collaborate with other apps and other people making music. So first, a little bit about me. I worked for a long time in Japan, making music games for Nintendo DS and PSP and Xbox and things like that. And then after a while, I wanted to be more closer to the making of the music instead of just games built around it. So I came to Propellerhead in 2013. I've been working on all of our mobile apps since then. I'm also the manager of the mobile group, which I'll talk about in a second. And I like taking pictures and making music. So those are some of my hobbies. What inspires me a lot is creative tools. It's tools that allow us to find ways to express ourselves in ways we didn't think possible before, or tear down the walls that get in the way when you have something in your heart that you want to share on the outside. So not only using those tools, but making them too as well. At the mobile group at Propellerhead, we have 4 developers, a tester, owner, and a designer, and a partridge in a pear tree. And what we do is we work on the 4 apps that Ernst mentioned. Rebirth and Thor are our more professional apps that are towards the more pro market. And Figure and Take are now apps made by Alihupa that Ernst was describing. Figure has been around since 2012, but recently we've shifted development and branding of these two because they work so closely with the Alihupa service. As Ernst mentioned also, we have apps, or an app on Windows. Figure runs on Windows 10. If anyone is a closet Windows phone person, you can grab it for free. It runs just as great. And all of our stuff is built on our Reason technology. Reason is the name of our flagship professional product. Ernst threw out the TLA, the acronym DAW, which is Digital Audio Workstation. That's your big honking software suite on PC and Mac, which you can use to do everything from humming in the shower to creating award-winning music. But that audio technology is what's inside of all of our apps. So, interprocess audio. This is really cool because apps do not need to be vertical slices of how to do things. And that's especially true in audio. So you can focus on what you know as a developer, whether it's filtering or producing a timbre and an instrument, or something that sends MIDI messages, or something that takes music produced somewhere else and then converts it to a format that you can share with people. So you can use this to focus on just one part, do it really well, and then have your app work with other people's apps in a unified format that's standard on iOS. So the things you can do with interprocess audio is you can generate audio. For example, if you're a synthesizer or you're a virtual piano, something like that. You can send MIDI messages. MIDI messages are for controlling hardware or software through a unified system. You can record audio, or you can take the audio that's been recorded and sequence it together. So, I'll try to keep it light on the jargon here. How many people have heard of MIDI before? Okay. How many people have heard of inter-app audio? Okay. How many people have heard of audio bus? Okay. So I'll try to keep it just around sticking to MIDI as a known factor. So MIDI, like we said, it's about for combining instruments, sending messages between them, physical or digital. Inter-app audio is Apple's tech for routing audio and control messages between processes on iOS. Audio Bus is a third-party app that does the same thing. It actually came before inter-app audio. I'll get into that, the history of that in a minute. And audio units are a way of taking your app and having them function as a plugin. App extensions have been introduced in iOS 9. And audio units is one type of extension that you can build. So your code is entirely run under a host of some other process. In inter-app audio, you can have generators. Those are nodes in the graph of things that make sound. What the generators make the music, and instruments create MIDI. So you think to yourself, okay, I want to hook up my music app with some other music apps. How can I do this? Okay, you have 2 options. First, we start with, are we talking real-time or offline? Real-time is what you would use if you want to perform, if you want to play, or if you want to record audio on the fly. Offline is if you want to take some audio that you've set up in advance in an app and then render it to a file format and then be able to compose those together to make a more sophisticated song later, either on iOS or on the desktop. So I'm going to talk about real-time audio processing first, because that's the bulk of it. So you have a number of options, and I'll go through them chronologically in terms of when they were introduced. Core MIDI is part of iOS, which has been around for a really long time. It came over from OS X, and basically it's just Apple's implementation of MIDI messages. You can use it to send messages between apps and hardware. One way you could do this is if you had a physical plastic keyboard and ran a USB cable into the camera connection kit, and then if you play on that keyboard, you can use it to control a virtual piano, which will then drive the audio. Obviously, there's limitations in what kind of fidelity you can get out of a virtual keyboard on the screen. The tactile response is just not as good as the ivory underneath your fingers. This is very easy. You just need the platform services, and you can have your MIDI app run as a slave or a host. It just means receiving or sending messages. The next option is Audio Bus. This has been around since the era of iOS 5. It's developed by two developers named Audionica and Tasty Pixel, the name of their companies. And what it does is it routes audio between senders, filters, and receivers. So apps that send audio, apps that process audio, and apps that receive it. And it does it through ports inside of iOS. This was pretty cool, and it happened rather smoothly for a while. And then iOS 7 was introduced, and Apple had been looking at Audio Bus, and I assume they thought, okay, this is really cool, we should do it ourselves. So inter-app audio is kind of like Audio Bus, but not exactly the same. So for Audio Bus to continue to function with iOS 7, they had to change their implementation to piggyback on top of inter-app audio. As you know, progressively the security protocols in iOS have become tighter and tighter, and it's become less, there's less loopholes to work on moving things back and forth. You can use Audio Bus just by adding their static library and then integrating with some render callbacks. It's fairly simple. The number of clerical procedures you have to take care of with most of these things I'll talk about in the future involve adding keys to your P-lists, setting up things in your entitlements, and that kind of stuff. But once you check off those boxes and define all of the boilerplate for specifying how your app should function, it's pretty simple. Using Audio Bus now gives you inter-app audio generator support for free. And since it's built on top of inter-app audio, just by using the Audio Bus SDK, you automatically get inter-app audio. So if there was another app out there that only supported inter-app audio but not Audio Bus, your app could then interact with it in terms of sending audio. And you can also have multiple ports defined for a single app. You could both send audio and receive it. If you imagine like a loopback thing, maybe like if you're broadcasting sound and then want to record how it's been going through a filter or something like that. So I'm going to give a short demo now. I have two demos, but getting into the demo mode is kind of difficult for Stefan, so I'm just going to do the first one on the iPad and save the second one for changing cables and stuff. So what I have is an app called Audio Share. I didn't write this. This is by Jonathan Littledahl, another Swedish developer. And what he has here is an app that basically records from a number of sources and allows you to manipulate the file. So on this page, I go and I choose my input. I have a list of inter-app audio sources. I can pick one of those. In this case, I'm going to use Figure. Okay. So now I've launched Figure. Tapping on it launches the app. And then what I can do is I go back to Audio Share and I hit record. So it's monitoring the stream now that Figure is going to be producing. Go back to Audio Share, stop. And now it's kind of hard to see, but I have a WAV file rendered here that basically just took the output that came from Figure and recorded it into a buffer on Audio Share. So now that I have it here, I can slice it, or I could fade it, trim it, normalize it, or I could share it to SoundCloud or iCloud or email it and other things like that. So Figure does not have to worry about all these extra sharing formats because it can talk directly to Audio Share. And Audio Share can handle the heavy weight of doing the processing and the sharing. The next option is inter-app audio, which I just showed you. This has been around since iOS 7. it requires the same things now as Audio Bus. It's some plist stuff, and then you integrate it with your render callback, which is where your audio is produced and or processed. What you can do recently is you can use Interrupt Audio to also sync. So you can start multiple apps at the same time to make sure that your drums and your lead and your piano and all that stuff comes together if the app supports Interrupt Audio sync. Next, most recently, we have audio units. As I mentioned, this is an app extension. It's not an actual app. You can specify it just as you would any other app extension, and you set the type to be audio. You modify this, and then you respond to host requests. How many people know or have used app extensions before? Okay. So there's some challenges with app extensions in that you don't have you can't get access to the application delegate and things like that, because it's really more compartmentalized in the sandbox way of running things. But other than that, you can easily use the same code to do your app as an audio unit or as the full-fledged audio app itself. I don't know a lot of audio apps that use this just yet. I know a couple, very prominent ones, but the reaction is positive. And I know that people who do a lot of pro audio are probably looking forward to this, because audio units is a principle that's existed for a long time in OS X. So now that a developer who maybe has only been on OS X previously has built their audio unit plugin and sold it, they could just port their code very easily on iOS and then sell it in the App Store there. As addendum to this, synchronization is one part that's worth mentioning again. As I said, you can use real-time processing for performance. This is very, very important, obviously, that everything in the music plays together at the same time. If you're off by so much as a few milliseconds, it can feel really uncomfortable to someone listening to the music when the drums are out of sync with what's being played on the keyboard. So there's a number of ways that you can fix this. Core MIDI began with that, and the host-slave system. You can use it for setting the tempo and also telling all of the nodes in the MIDI system when to start playing. Another one is that WIST technology developed by Korg. This has been around for a few more years than the Interrupt Audio, but Korg developed this, and it allows you basically to use GameKit and Bluetooth to synchronize playback of audio apps. You have to integrate the SDK of WIST into your app to get it to work, but it's also not so complicated. I mentioned Interrupt Audio Sync. And finally, there's a technology called Ableton Link, which has been introduced just very recently. Ableton is a company in Germany that also does audio production. They have their own desktop system. But the Ableton Link is an SDK for iOS that allows apps to all work together in a much more flexible and a collaborative system than you get with WIST or Core MIDI. There actually is no master and slave in Ableton Link, and everyone can submit requests for tempo changes and things like that. You can also drop in and out of a session ad hoc whenever you want without disturbing what's going on with other people. So that's sounding really cool. I know a lot of the cutting-edge apps are adopting this SDK. So now we're going to try to do some acrobatics with cables to see if I can get something on the bigger screen for you. Okay, so what I have here is Audio Bus, and I've set up 4 generators over on the left-hand side. I have Animoog, I have Thor, and Figure, which are 2 apps, the 2 middle ones that we develop, and then Fugue Machine. Fugue Machine doesn't actually produce its own sound in this case, but it sends MIDI to Animoog and Thor. So let's see if I can get this to work. So I just laid down here on Fugue Machine a very simple chord progression. And I have 4 separate playheads which are flying over the piano roll here. And 2 of the lines are sending notes to Thor, and 2 of them are sending notes to Animoog. And I can toggle them off and on. And then I could jump over to Figure if I wanted. So then I could use that to hook all these instruments together. I could be recording my music. Can you turn the volume down, please? Thanks. Or I could run it through filters or things like that. I don't have time to give you a full demo now. I can show you later if you're interested, but here I could add effects to process and add reverb or delay or high-pass filters, things like that. And over here I can add targets where I want to record and split that audio, things like that. Okay, so I'll continue with offline audio processing. This is the opposite of real-time. Obviously, like I said, it's if you want to take the audio data, package it up, and then mess with it later, either on desktop or on your machine. Originally, there was something called the UI pasteboard. Well, I mean, it still exists, but it came around in iOS 3. And what you could do is use the pasteboard general for shoving any kind of data you want in there between. This is fairly simple to do as well. What you do nowadays is you give it an array of dictionaries of data that you want to submit. For example, if I rendered my song on Figure, I'd have a WAV file, and then give it that and call it my best song, and then shove it over to the pasteboard controller. And then some other app that supported the pasteboard could then iterate all the pasteboard types, which had like AIFF audio data file, and then grab it and then copy it into their app. There's a company called Sonoma Wireworks. They took this a little bit farther and developed something called Audio Copy, Audio Paste in 2010. It's now maintained by Retronyms, a separate company. What this does is it extends the pasteboard to be more user-friendly in terms of audio things. You can add metadata, you can have custom apps and UI view controllers to iterate that data in more useful ways, and it makes the experience a bit more friendly. Originally, there was a custom pasteboard used by AudioCopy, but iOS 7 broke this, so there was a time that it was down. And the developers confined it then to using the general pasteboard. It broke again in iOS 9 with the increased security protocols and the ways of launching apps and query schemes and things like that, just the way the AudioCopy library worked. But now that's working again. So what this requires is you just install the AudioCopy SDK, and you do a series of URL schemes and permission changes to your info plist, similar but different to Interrupt Audio. So yeah, you just render an IF file, then you hand it off to a UI view controller that comes from the SDK. And that user experience is a bit friendlier and more tailored to people who are doing audio stuff than using the general pasteboard. The third option is not really an option, but it's worth mentioning anyway, that you can use iTunes file sharing or iCloud or whatever. Since we have that rendered audio file, then it's just a matter of getting it in the user's hands so they can mess with it in some other place. It's very cheap. Just add that to your info plist, and then you can take that audio file and copy it somewhere else. Then the user can go dig it out and use it on their desktop. So, how hard is this? Like most things that don't have real-life analogs that are easy to understand, you have to get used to it. You can forget how things operate. The documentation in the developer center is kind of thin. It's not the most robust area of Apple's documentation. And errors, you usually get hex codes to the device log, and that's about it. And you're just sitting there like, why am I not getting any sound, damn it? And then you have to go hook it up to a monitor and hunt it down. I actually have 2 devices for those 2 demos because I was getting a situation where I couldn't show you both of those things without creating a cascading failure of interrupt audio errors, just where the nodes won't hook up and it just won't play any sound. There are still platform bugs actually that exist with this that Apple has broken over time. They fix some of them and other ones that are still not fixed. And there's forums that list all the bugs that are in iOS that are still not fixed, just so you know when you're trying to develop that it's not just you going crazy about these things, and it's expected. There's a good community, but it's spread over a number of forums that is not Apple forums and things like that. So you have to get into the special group to make use of it. Yeah, and things break often and routinely. WIST was broken for half a year between iOS 8 and 8.3, I think, because Apple broke something in GameKit, and then it just made the peer matching unusable in WIST. But when it works, it's really, really cool, as you can see. So to sum up, it's great because you can just focus on one thing, making sound, filtering sound, recording sound, just do that. let other people who are better than you focus on the other stuff. And there's boatloads of really cool apps that have all this inter-app audio and audio bus support for them. It's hundreds and hundreds. So it's really cool, a lot of cool stuff out there. And iOS can be great to combat writer's block. Like I showed you with Fugue Machine, that app that sends MIDI in 4 different channels at once. A lot of times I've sat down at the computer and looking at the huge screen of Reason, and then I'm like, okay, I'm gonna write a song. What am I gonna do? And you get that kind of lockup just from seeing the infinite possibilities of a timeline. But with apps like Figure and Fugue Machine and lots of really others, there's all these different ways to use the touch screen and novel interfaces for creating really beautiful music. And of course, this is hands down better than anything you find on Android or Windows. Like I said, it's hard to get your head around. Debugging is really annoying, and you can't do it in the simulator, obviously, because you have to have ports set up and apps actually installed, third-party apps to get that running. Yeah. The thing that bothers me personally most is that it's not safe for live performance. I've been a number of times where I was just playing and I was like, oh, this is great, the crowd's gonna love it, and then the sound just stopped or something like that, and because there was some kind of Bluetooth matching problem or something got out of sync. And it's fun, but you really need to have backups in the event of things just stop working. So thank you for your time. There's some links here about good information. You can come find me on mail at Allihopa. And we're looking for some new developers to help us build this great Allihopa stuff. So come talk to me if you like. Thanks, guys.